The latest news about 3I-ATLAS has been deliberately kept secret, with countries, including NASA, collectively choosing to remain silent. Today, one video will explain everything clearly. As the first interstellar object to enter the solar system in 6 years, since it was discovered by NASA's ATLAS telescope in early July 2025, scientists around the world have been in a frenzy. In just 2 months, related research papers skyrocketed from 4 to nearly 70. Now, with only a few days left before it reaches perihelion on October 30th, this comet, traveling at a speed of 58 kilometers per second and possibly more than 10 billion years old, holds countless unknown mysteries. The name 3I-ATLAS has 2 meanings. It is the third interstellar object discovered by humans, and it commemorates the ATLAS telescope that found it. The previous interstellar visitors we've seen were Oumuamua in 2017 and Borisov in 2019, but this one is different. It flies faster, is much older, estimated to be between 3 and 11 billion years old, almost the same generation as the early solar system. Most importantly, it's now approaching the sun, and with every step closer, it reveals things we've never seen before. On July 21st, when the comet was still 446 million kilometers away from Earth, the Hubble Space Telescope captured a crucial image. The background stars appeared as streaks, showing just how fast it was moving. Even more remarkable, the coma and surrounding dust took on a teardrop shape. Based on this photo, scientists calculated the comet's true size. Its diameter is between 440 meters and 5.6 kilometers, much smaller than initially estimated. What we saw before as bright light was the dust cloud, not the comet itself. Now that the dust has dispersed, its true form is revealed. Soon after, the James Webb Space Telescope joined the observation. On August 6, Dr. Connor, an astrochemist, led a team using Webb's near-infrared spectrometer to analyze its composition, and discovered something even more interesting. The comet's coma structure was unusually complex, and strangely, while most comet tails point away from the sun, 3I-ATLAS had a large amount of dust spreading toward the sun. Another unexpected discovery came from the Transiting Exoplanet Survey satellite TESS. Previously, scientists thought the earliest observation record of 3I-ATLAS was on June 14th, but the TESS team, after reviewing earlier data, found that they had already captured the comet between May 7th and June 2nd. Comparing the brightness data, scientists confirmed earlier measurements and verified that the comet's activity level was far beyond expectations. In addition to photographs, ground-based telescopes also measured its spectral lines. Assistant Professor Yang Bin from Thales University found continuous CN emission features in its spectrum, indicating that the comet was releasing cyanide molecules. Normally, such emissions appear only when a comet is within 3 astronomical units of the Sun, and 3I-ATLAS happens to be right at that distance now. More importantly, by analyzing the ratio of C2 to Cn, scientists classified 3I-ATLAS as a carbon chain-depleted comet. In simpler terms, its coma and tail contain very few C2 and C3 molecules, long-chain carbon molecules that usually indicate the environment in which a comet originally formed. Recently, a new breakthrough emerged. Scientists began studying the comet's light polarization characteristics. On September 5th, the Zurich Gray team published a paper revealing the first polarization observation data. They discovered that 3I-ATLAS had a unique feature, an unusually deep and narrow negative polarization branch. In simple terms, the way it scatters light is unlike any comet or asteroid we've seen within the solar system. It may even belong to an entirely new class of small celestial bodies that we do not yet understand. Now, the most anticipated event is October 30th, when the comet reaches perihelion, about 1.4 astronomical units from the Sun. Unfortunately, because it will be too close to the Sun, we won't be able to observe it directly for a while. Only in early December, when it re-emerges from behind the Sun, can observations continue. But there's no need to worry. Every astronomical instrument around the world will be watching closely. When it reappears, a flood of new data is sure to surface. Finally, the ultimate question remains: How long has this comet been traveling through the universe before reaching our solar system? Can we trace its origin? These answers must wait for future observations, but one thing is certain. The truth is already very close to being revealed to humanity.